The last thing I want to talk about in this section is something really fun. Now we're going to do row, column, and null space under modular arithmetic. So this is going to be awesome. Last example for this section. Suppose we are under, I'm going to do Z5. And we have this matrix A. Directions say find row, column, and null space. So this is not one we can pop in the calculator. We get to do a good old-fashioned RREF. So my first step, I'm going to take row 2 and I'm going to replace it with row 2 plus 2 times row 1. And then I'm going to, row 3 is actually good, so I don't have to do anything there. The goal is to eliminate that term. And since I'm under Z5, remember Z5 only consists of the numbers 0 through 4. So those are the only numbers I can use. Row 1 stays the same. I have row 2 is row 2 plus, this needs to be a 3 times row 1. 2 plus 3 is 5, which is 0. 1 plus 6 is 2. 5 plus 9 is 4. And 6 plus 12 is 3. The second row stay the same. So now we really want a 1 right here. And we can't multiply by 1/2. 1/2 does not live in this world. So let's take row 2 and replace it with 3 times row 2. Because 3 times 2 is 6, and 6 under mod 5 is 1. And having that 1 in that key spot will make the next step easier. So 3 times 2 is 1, 3 times 4 is 12, 3 times 3 is 4. Now we need to zero this guy out. So we're going to take row 3 and replace it with row 3 plus 3 times row 2. Two plus 3 is 0. 4 plus 6 is 0. And 0 plus 12 is 2. So now we need a 1 here. So row 3 is going to be 3 times row 3. Now we want to zero out these. I am going all the way to RREF. I just think it makes it easier. So row 1 plus row 3. 4 plus 1 is 0. Row 2 is row 2 plus row 3. 4 plus 1 is 0. And then I'm almost in RREF. I just need to zero this out. So let's take row 1 and replace it with row 1 plus 3 times row 2. So 2 plus 3 is 0. 3 plus 6 is 4. So there's my RREF. So let's talk about row space. I have a leading one in each row. So I have to have three rows in the row space. Let's talk column space. My leading ones are in the first, second, and fourth rows. So those are the columns I have to use, going all the way back to this original up here. So I have to use the first, second, and fourth. So my column space, first, second, and fourth. And then we've got null space. So let's talk about this null space. Remember, null space we augment with the 0 vector. So we're going to get x1 is equal to negative 4x3. x2 is equal to negative 2x3. Notice I've written these in both the terms x3, so x3 has to be free. And then x4 has to be equal to 0. Now, under this world, remember we're under Z5. Under this world, a minus 4x3 doesn't make sense. But what does make sense is x3. So you have to mod that number in front. Same thing here. We got to mod that negative 2, so that becomes a 3x3. So then our null space is the vector 1, 3, 1, 0. How cool is that? So I also want you to notice before we tie this one up, the orthogonality still holds here, right? We said that the row space of A is going to be orthogonal to the null space of A. So you can always use that as a great way to double check. So if I take V1 and I dot it with V4, I'm going to get 1 times 1, which is 1, plus 0 times 3, which is 0, plus 4 times 1, which is 4, plus 0 times 0, which is 0. That's 5, but under mod 5, 5 is really 0. If I do the same thing with V2 and I dot with V4, 0 times 1 is 0, 1 times 3 is 3, 2 times 1 is 2, 0 times 0 is 0, 3 plus 2 is 5, but 5 is really 0. And then if I dot V3 with V4, I'm going to get 0 times 1 is 0, 3 times 0 is 0, 1 times 0 is 0, 1 times 0 is 0, so I get 0 there. So you can always check your orthogonality here, but all of those rules hold whether we're under the real numbers or we're under some modular arithmetic form. It's really kind of cool to think about all that. So that concludes this section, and we'll move on to the next section in the next video.